rectify the half cycle. So either the positive or the negative cycle according to the diode connection it is rectified. We will be having a transformer which will step down the 230 to 12 volts. So we know that from the circuit I can write I need a diode, a step down transformer, resistor, capacitor, breadboard connecting wires and a CRO. Now we will move on to the breadboard connection. So this is my breadboard. Place all the components. Okay. Now from the input it is given to the transformer, and the other end of 12 volt is given to the anode. Cathode is given to your resistor. Other end of the resistor is grounded. Now the 0 volt will be grounded from the transformer. From the CRO it is connected across your resistor. Okay, you will see the same in your virtual lab. So I'll connect it to your, the sine wave is connected to the anode to the one end of the resistor, the other end of the resistor is grounded. Channel 1 to the sine wave, channel 2 to your oscilloscope, from the oscilloscope to your resistor point. Check the connection, it is showing correct. So now let me set my resistance value to 1000 ohms, switch on the circuit. Produce your sine wave, switch on the oscilloscope. Sine wave will be having an input wave like this. If that is rectified wave, half of the cycle is removed. So this is regarding your half-wave rectifier. We see the filter. Now I am going to fix the filter across the resistor. So the positive will be your longer lead, the negative will be the short lead. So the longer lead is connected to the resistor, shorter lead is grounded. Okay, so now the same thing we will see in the virtual. So I'll switch on the circuit. Rectified means I'll be getting the rectified output. If I'm using a filter, I'll remove the AC ripples and I'm going to get a perfect DC waveform. For higher value of capacitor, you can get a straight line. Now we will move on to the full hardware demonstration in the lab.
Transformer, single phase transformer. This side is primary section, this another side is secondary section. Secondary section is 12 0 12. The center tapped transformer is used. This single phase half wave rectifier 12 0 is used. The anode is positive, this side is cathode is negative. The output will be shown in the CRO. This is a single phase half wave rectifier output. Measure the amplitude and time period. The input of the half wave rectifier, the anode side is positive. CRO positive will be inserted in the input side. This is a half wave rectifier of the input side. Input side is 230 voltage. It's a sine wave. Measure the amplitude and time period. The output is half wave rectifier. Measure the amplitude and time period. Another measure the values using multimeter. VAC and VDC voltage is measured. First of all, the measure the VDC voltage. The multimeter positive terminal is connected in resistance one end. Another end is in the resistance another end. This measure the value of VDC voltage. Again select same procedure for the resistance is connected. Measure the value of VAC voltage. The another circuit for with filter. The same circuit, one electrolytic capacitor will connected. Positive terminal and negative terminal connected will ground. 100 microvolt and T volt. This output will measure the with the filter. Measure the amplitude and time period. Again VAC and VDC voltage. Same procedure for with filter. So VAC voltage. Again select button. VDC voltage. The tabular column of the without filter and with filter.
Okay, so we will see the waveform which is captured in the CRO. So you will have an input wave in one channel, the other one will be the output wave in another channel. So I'll show you. You have to check the knobs. You will be having all the three knobs as here in your CRO. So now I'll measure the time period. If you count the boxes, it is four boxes it is having. Now I'm going to see what is the 5. It is showing me, the knob is showing me 5 millisecond. The arrow mark you can see. So 4 into 5, it is 20 millisecond. Again, measure the amplitude. It is two boxes. The knob is showing me 10 volts. So 2 into 10, 20 volts. So this is your CRO measurement. VDC is measured from your multimeter. So gamma is equal to VAC by VDC, which is 1.23. Now I'll move on to my capacitive filter. Same thing. I'll have my input wave, then the rectified output. So this is my time period. As usual, it is four boxes. So 4 into 5, 20 milliseconds. And then the amplitude 2 into 10, 20 volt. So using your multimeter, measure your VAC and VDC, which is going to give you 13 and 1.23. So gamma is equal to 0.094. This is your